Okay, our last video is going to be looking at this Intro to Correlation Excel workbook that should be up on our Blackboard page. And I only want to just briefly work through some of it, and it's set up so that you can go through it, play with the examples, and really kind of get an understanding of how correlation comes into play as you change things, what it looks like, all of that sort of stuff. So some things that don't really get mentioned here that play a part in all of this are things like variation, variance, covariance. All right, and then whenever we refer to the SD line, we're just talking about the regression line or line of best fit. All right, SD is used for standard deviation here. So in this workbook, there's some SAT data for applicants to a college, and we're going to go through and kind of see some of the data and see how, as you play with it, things change, what the correlation coefficient really does, means, that sort of stuff. So I'm just giving you an insight, and I encourage you to, or an overview, I'm encouraging you to look through it on your own. So for example, here we have 527 applicants in a recent year, in the 90s. It's not a recent year. All right. And we've got their verbal and math scores on the SAT. We've got here, so these are the data points, right? So in this row, we have one individuals, all right, both verbal and math scores. And so we've got an average, all right, here for the verbal, and a standard deviation for the verbal. All right, and here we've got an average for the math portion and a standard deviation for the math portion. So some built-in questions here are, given that we know what the average is and the standard deviation is, can you think of what the histogram is going to look like? Can you use the average and standard deviation to create a mind's eye picture? In other words, to just visualize what's going to go out, it's going to look like in terms of a histogram. And then if you want, you can scroll down. I'm not going to scroll there down and test your intuition. All right, but we've gathered this data. We've figured out the averages and the standard deviations for each of them. All right. Over here, all right, a univariate scatter plot, univariable or one variable. So all we have here is the verbal SAT. All right, and we've got paced along here, right, the different point at each value in the verbal SAT for the scores. But there's no meaningful axis here. There's no value here that's meaningful. So a bivariate scatter plot is, now we've got here on the x-axis verbal SAT scores, and here we've got the math SAT scores. And so here's what our data looks like. All right, and so below you can make a 3D histogram of this data as well. I'm not going to spoil that for you either. All right, but we've got all this data. All right. And here, what we've done, or what has been done for us, is that we've computed the average math score given a verbal score. So, given some verbal score, all right, we averaged the math scores of every individual that had a verbal of 300. Okay, so maybe there were 5 people who had 300 verbal, and this is their averaged out math score. Just something that's interesting to look through, read through if you're curious about it. So for example, well, I'll let you explore that. But here's where it starts to get interesting, all right, or it gets more interesting again. All right, we've got all the data gathered here again, verbal scores and math scores for each individual, and we've got the averages for each of them. All right, and we've got the standard deviations for each of them. And so what we've done here is, if you look up here in the function bar, we've got the correlation, right, of A3 to A529, right, all of these values with, and that's our x, those are our x values, our x data points, with our y data points, and we've got those cells marked off as well. The colon means through. In other words, we're getting all of them, so you don't have to list them all. All right, that's as easy as that's how easy it is to compute the correlation coefficient in Excel. It's literally just this command. All right. So here's our scatter diagram. Okay. Now, if I click on average, all right, what it does is it gives me my scatter plot. All right, and then it's got 2 bars, a vertical bar and a horizontal bar, lines, vertical line and horizontal line. This line corresponds with, well, the average verbal score, right, which is 512, right? this line corresponds with the average, right, math score, which is 595. Now, if we press the SD line, all right, we get our line of best fit, right? Our line that minimizes the vertical distance, the square actually, of the vertical distance of all of our points from, well, a line. So we draw this line. I'm actually going to do the line with our averages. If you see that our line should pass through the intersection of these averages, okay? And so we've got now a line of best fit that if we wanted, we could use to make some predictions. Well, the key is, how good is that line? Well, here's our correlation coefficient, 0.55. Okay, so technically, right, or well, here's the quiz: is that a weak, medium, or strong correlation? Right? We would want to know, because that would tell us then how good is our line of best fit. Right? How comfortable do we feel, right, with that giving us some predictive power? In this worksheet, I've also got extreme cases. So, for example, here's a perfect correlation, positive. Here's a perfect negative correlation. All right, and here's a zero correlation, no correlation. All right, and there are also some things to look at in terms of patterns. This one I think is really helpful if you come through and you say, all right, I want to have a correlation coefficient of 0.75. Okay, and I can alter my averages in terms of my y variable, my average, and my standard deviation for my y variable. And then once I change my r, or change any of my parameters, all right, so maybe I want my standard deviation to be 10 this time, I can generate y, and so it'll generate, all right, data points that satisfy these criteria. So what would my data have to look like in order to yield 0.75 R, 75 hundredths R, and a standard deviation of 10 for Y? Right? What if the standard deviation was 20 for Y? So what's changed? That's a good question. Right? Now, one of the other things I like is we could view misleading R. Oh, never mind. We can't. All right, I forget. I haven't fixed all the code, the macros. But we can cycle through R's. So here's a perfect correlation, negative, right? Here's something that's negative 8/10, right? Negative 5/10, or negative 1/2, right? Negative 1/4, so very weak correlation. No correlation, right? Weak correlation, medium to strong correlation, right? 0.5, and then strong correlation, right? And then perfect correlation. And then finally, the last thing is going through, and if we change values, it'll recompute. Once we click computing R, it'll spit out the new correlation coefficient, the new averages, standard deviations, everything. So I increased that Y from 4 to 10, right? And so my R, right, has decreased, if you notice, right? So click on cells to reveal the formulas used. All right. Another thing that's useful is to go through and sort of go through that as we. Anyway, long story short, all right, this one doesn't seem to be doing what I thought it was going to do. So, the idea is to practice with this to try to get a handle on it and understand correlation coefficients, how they change, how to interpret them, and really what use they are in terms of giving us an understanding of when things do and don't correlate and what that means.